Hello everyone, welcome back to my YouTube channel, Code for AI and Data Science. In today's tutorial, I am going to build up the heart failure prediction system using Python. This is the machine learning model that would be based on the random forest classifier. In our previous tutorials, as we have already covered how to do the data importing, data exploration, and data pre-processing. Apart from this, we have also covered some of the topics like Canaan, Nye-based classifier, diabetic disease prediction system, and the various performance metrics which are generally used to evaluate the performance of the machine learning classifiers. And in this tutorial, I will only be focusing on the building of the heart disease prediction system using the random forest. Before moving on to the coding part, let's understand the workflow of the heart failure prediction system. Here we can see the heart disease dataset, and we will apply the data processing over this heart disease dataset in order to get the more refined data. Once we get the more refined data, then we will split the data into the ratio of 80% and 20%. The 80% of the data will be used to train the machine learning model, and the 20% of data will be used to test the machine learning model. After splitting the data into the ratio of 80 and 20%, we will simply apply the random forest classifier. That means we will build up the random forest classifier for the prediction of the heart failure disease. Let's move on to the coding part. Here we will use the Jupyter Notebook environment to build this project. Jupyter Notebook environment is available on the Colab. As we have seen in our previous tutorials, we have been using the Colab to build the projects. So here also we will use the Colab. You can easily access the Colab using your Gmail ID. This has already been taught to you many times in our previous tutorials, so you can refer the previous tutorials if you want to know how you can access the Colab. So here we are going to use the Jupyter Notebook environment that is available in the Colab. So before building the project, first of all we need to import the required libraries like NumPy and Pandas. So first of all we will import the NumPy as NP and Pandas as PD. The NumPy is required to perform the mathematical calculations on data, and Pandas, which we are importing as PD, is required to access the data. And to import the required library, we will run this cell, and if the command is correct, then you can see the tick mark here, and if the functions which you are using are not correct, or the syntax which you are using here is not correct, then there would be the red mark here. But here you can see the syntax are correct which I am using. So next we will load the data set. As you know that we are working on the heart failure data set. So this data set has the two classes, the first class and the second class. In the first class represent whether the person is going to have the heart failure or not, and if the person is going to have the heart failure, this class will be represented by 1, and the second class is represented by 0, and the second class represents that the person is not going to have the heart failure. In order to load the dataset, first of all we will have to upload the dataset on Colab with the help of this syntax. And here we will first of all we will import the files from google.colab, and then we will use the function files.upload to upload the dataset on the Colab. So run this cell to upload the dataset on Colab. So here we will upload the dataset heart failure data. As you can see that this dataset has been uploaded as heart_failure_data_1. So we will simply copy it, Control C, and then paste this file name here. Then we will use the function pd.read_csv to read the dataset. Click the cell to read the dataset. That here you can see the tick mark. This function has already read the dataset. Now in order to display some records of the dataset, we will use the head function. So we can use the head function in order to display some records. Here you can see the 5 records of the data. The records are being started from 0 index and going up to 4. So here we can see the 5 rows basically, first row, second row, third, fourth and fifth row. So automatically this head function will extract the 5 rows. If you do not mention here any number, it will extract the 5 rows. If you mention the number, then whatever number you mention here, this function will extract the same records. In order to have the insight about the data, means what kind of data we are having, so we simply use the head function, and if we want to display the last records, then we use the tail function. But here I am simply using the head function in order to display the first 5 rows. Here we can see the 11 input features: first, second, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th and 11th. And the 12th feature is the target level, means this is the output class, which is representing whether the person is going to have the heart failure or not. So as I have mentioned earlier, if the person is going to have the heart failure, this would be represented by 1, and if the person is not going to have the heart failure, it would be represented by 0. These input features are known as the independent features, and the last column, which is the target level, is known as the dependent feature. As I have already mentioned many times, why this target level is called the dependent feature, because this target level depends upon the previous input features, means whether the person is going to have the heart failure or not will depend upon these independent features. So these independent features will decide what is the age of the person, what is the sex, whether the person is male or female, what is the cholesterol pain level, and what is the BP of the patient at rest while the patient is at rest, and what is the cholesterol level, and what is the sugar level of the patient while he is at fasting. So all these features will decide whether the person will have the heart failure or not. So that's why these features are known as the independent feature, and the last feature is known as the dependent feature. This last feature or the last column will depend upon these 10 features. In the next step, we will use the group by .size function in order to see how many instances belongs to which class. ये देखने लिए कि आपके जो हैं कितने इंस्टेंसेस किस क्लास से बिलोंग करते हैं, हम इसमें जो है ग्रुप बाय फंक्शन का यूज करेंगे. Here you can see the 138 samples belongs to the 0 class, means 138 sample belongs to the healthy class, and 165 samples belongs to the unhealthy class. That means 165 samples of the patients are going to have the heart failure, and this 0 indicates that the 138 samples are the healthy samples and they are not going to have the heart failure. So just to know about the number of samples, how many samples we have, from which category how many samples we have, we can simply use the group by function. And in the next step, we will use the describe function in order to get insight about the data set, what kind of data set we have, what is the mean value, what is the standard deviation of the data set. So we will simply use the describe function. Now run this cell. Here you can see the description of the data set, the number of counts. As we can see, in all the columns, means in the first row and all the columns, we are having the 303 value. That means the total number of samples we are having are 303, and the mean value of this age column is 54.366, and the standard deviation of the first column is 9.08, and the minimum value of the first column is 29. Means whatever value the minimum value of the first column is 29, and the maximum value is also mentioned here. The maximum value of the first column is 77, means the maximum value in the age column is 77 and the minimum value in the age column is 29. So here you can see the description of the data set and what this 25 percentile is representing and 50% percentile is representing. This 25 percentile is representing that the 47 means 25% of the samples are having the value lower than 47.5 for the first column, means for the age column, and likewise the 50 percentile is representing that the 50% of the samples are having the value lower than 55 in the age column. Similarly, the 75 percentile is representing that the 75% of the people or the 75% of the samples are having the value lower than 61 in the age column. So here we have already understood the meaning of the percentile: 25 percentile, 50 percentile and 75 percentile. Now we will go to the next step, that is splitting the dataset. In the next step we will split the dataset. But why we need to split the dataset? As I have already mentioned that we have the input features and the output class. That means we have the independent features and dependent feature. So in order to separate the input features or the independent features and dependent feature, that means the input features and target label, we will use the ilog function. So as we know that in the above data we can see from the 0 index, means age will be at the 0 index, sex will be at 1 index, so the indexing will start from 0. So here we can see from 0 index to 10th index, means that is slope, we are having the input features. So while we will extract the input features, we will use the index 0 to 10 and the target level is at the 11th index. So in order to isolate the target level, we will use the 11th index in our program. That's why we will simply put the value 0 to 10th index in order to separate the input features, and we will use here the 11th index in order to separate the target level. So as I have mentioned that we are using here the ilog function in order to separate the input features and the target variables or the target label. Just run this cell in order to separate the independent and dependent features, and then we will execute the next cell also in order to print the values of the input features at index 1. This here you can see the values of the input features at index 1. So what is the data basically at index 1? You can check here. So at 0 index there is age, and at 1 index there is the sex, whether the person is male or female. So here you can see this is in form of 1 and 0. So simply all the value of this column, means this second column, we have extracted or we have simply printed by using this print function. Now we will move on to the next step, that is label encoding. Sometimes what we have the target label as a string or as a text, means here you can see in this data we have the target label as 1 and 0. We have the target label as a numerical value, but sometimes we do not have this target label as a numerical value. We simply have it as a yes or no, or we have it as a string or as a text simply. So if this is and this target label is given as a string or as a text, then we need to convert it into the numerical form simply by using the label encoding. We will use these functions in order to convert the data, string data, into the encoded form or into numerical value. But here we have already the data into the numerical form, so we need not to use this. So we need not to use this step, label encoding. We can skip this step, label encoding. If we use this step, even the data is in numerical form, it has no meaning. You can simply use it. If you want to skip it, you can skip it. So as it's not going to impact our data, the data is already in numerical form, so we can use it, or if you do not want to use, you can skip it, but I am using it here. So run this cell. In order to maintain the continuity, I use this step. Now we will move on to the next step, that is splitting the data set into train and test set. As I have mentioned in my previous tutorials, first of all, we will, whatever data set we have, we will split it into train set and test set. Just why we need to split the data set into train set and test set, this can be easily understood by this PPT. Here we can see we have the hard digit data set, and as you have already seen that we have basically isolated the input features and the target class using the ilog function. And once we separate out the input features and the target class, we need to split the data set into train set and test set. Generally, we split the data set into train set and test set into the ratio of 80 and 20%. So the 80% of data will belong to the training class, and the 20% of data will be used for testing purpose. And similarly, from the target class also, the 80% of data will be used to train the model, and the 20% of data will be used to test the model. Once we split the data set into the ratio of 80 and 20, then from the input features of from the input matrix, the 80% of the data will be used simply to train the model, and the 20% of the data from the input features will be used to test the model. Likewise, from the target class, the 80% of the data will be used to train the model. Means the 80% data we will have the label data. Basically, we will have the values either as 1 or 0, and similarly the 20% of data from the output class will be used to test the model. So here you have got why we need to split the data set. Now again, simply go to the next step. So first, in order to split this data set, we need to import the train_test_split from the sklearn.model_selection module, and then we can use this train_test_split function to split the data set. And in this function we will pass the argument x and y. Here you have seen what is the x and what is the y. X is the basically input matrix and y is the target class. And here you can see the test size. Here we are using the 20% of data as the test set, so you will mention here 0.2, and the random state is 15. Means you can use any value, or you can mention any value. You can use here 10 or 20, whatever you want to use. Basically, random state is mentioned in order to fix the data set. Once you split the data set, you already know what data set will be used for the training and what data set will be used for testing. So in order to fix it, means if you run the algorithm or you run the program multiple times, the data set should not be changed. Whatever data is being used as a test set and whatever data is being used as a train set, it should remain fixed. So in order to generally fix the data set, thus we use the random state here. So run this cell. Now we move on to the next step, that is feature scaling of the independent feature. As you can see in the data set, all the columns are having the different ranges. The age is having the different range. As you can see, in every column there is the different range, means data is having the different range. So in order to bring all the value into the same range, we need to perform the feature scaling. This step has already been repeated in our previous tutorials. So to know more about this step, why we use the feature scaling, you can refer my previous tutorials. So here I am just mentioning why we use the feature scaling. So as you have already seen, all the columns are having the different ranges, and in order to bring all the data into the same scale, we use the feature scaling. And for the feature scaling, we will import the standard scaler class from the sklearn.preprocessing module, and then we will simply create the scalar object, and thereafter we will fit the model over the training data by using scalar.fit_transform function, and we will simply fit the learning model to the training data, and we will also fit the model to the testing data. So to fit the model to the testing data, we will use the scalar.fit_transform. Now run this cell. Now this has been executed perfectly. Here you can see the tick mark. Now move on to the next step. The next step is training and predicting for classification using random forest. In the next step, we will use the random forest, and we will train the model and then predict the output using the random forest here. So to build the random forest classifier, we will import the random forest classifier from the sklearn.ensemble module. Once the random forest classifier is imported, we will build the random forest classifier model. Thereafter, we will fit the training. We will fit the basically model to the training data x_train and y_train. Once the model is trained, then we will use this model to predict the output values, and here we will pass on the test data to predict the output, and you can simply run the cell in order to print the predicted output. Here we can see the output, predicted output 0011. Means you can check whether the model has predicted the output correctly or not, just simply by cross verifying this 0 with the first. Here you can see the first value is 1 and the model has predicted it as a 0. So this is the wrong prediction, but our model has predicted so many values, so you need to cross verify it one by one. The second is also means in the input data set, in the target level, the second value was also 1, but here this is 0. So for the second sample also the prediction is wrong, but for the third prediction, for the third sample the prediction is correct. Means in the data there is 1, and in the prediction also you can see the 1. So you can match simply, means how our model performed. So in order to get better insight whether the model has performed well or not, we will simply evaluate the accuracy by using the classifier.score function. So simply run this cell in order to have the accuracy of the model. So the accuracy of this model is 73.7. That's quite okay. Now to have the confusion matrix, we need to import the classification report and the confusion matrix. If you want to know more about the performance of the model, so to know more about the performance of the model, we can use the confusion matrix. The confusion matrix will simply let you know how much our model got confused while making the prediction. And our model might predict the one class as the another class, and our model might predict the healthy persons as unhealthy and unhealthy person as healthy. So how much our model got confused, to know this thing we can use the confusion matrix. So in order to display the confusion matrix, we will have to import the classification underscore report and confusion matrix from the sklearn.matrix module, and simply run the cell. We need to simply add the class name also, class 1 and class 2. Here we are having the two classes, class 1 and class 2. So we will simply add the class names, and then we will pass the confusion underscore matrix and column names and index names, index values basically, to the function pd.dataframe in order to display the confusion matrix. And then we will simply print the classification report. In the classification report, we can have the precision, recall, f1 score values, and here we can see the for the 0 class, means for the healthy class, the precision is 70%, and for the class 1 its value is 77%, and similarly for 0 class the recall is 75%, and for 1 class the recall value is 73. And if the data is imbalanced, then we can focus on the f1 score also. The f1 score is simply the harmonic mean of the precision and recall. Here you can see the value of precision, means here you can see the value of f1 score. For the 0 class it's coming out to be 72%, and for class 1 the value of f1 score is 75%. Here we can see the confusion matrix. So अगर हमें और थोड़ा जानना है what is the confusion matrix and what is the precision and recall, you can refer my previous tutorial that is especially on the confusion matrix, or that is about the precision and recall. So by referring that tutorial we can know more about the precision, recall, f1 score, as well as about the confusion matrix. But here also we will have little bit information about the confusion matrix and precision, accuracy and recall. So this is the different example. Basically we are just using this example to understand the accuracy, precision and recall, and what is the confusion matrix. So here you can see the actual values and prediction. Along the columns there are the actual values, and along the rows there are the predicted values, the predictions made by the model. And along the columns we are having the actual values, actual data set. So here you can see along the first column we have the 82 negative samples, and along the second column you can see we have the 18 positive samples. And out of the 82, the 60 samples are predicted as a negative, means these 60 out of the 82, 60 samples are predicted as a negative by the model, and out of the 18 samples, 8 samples are predicted as a negative by the model. That means these 8 samples are actually positive, but model has predicted these samples as a negative. Similarly, in this cell the 22 samples are negative, but the model has predicted them as a positive. There are the 10 positive samples, and model also has predicted these 10 samples as a positive. So these 10 samples are positive actually, and model has also predicted them as a positive. So this last cell will represent the 3 positive, and the first cell will represent the 3 negative. This is the false positive, because these samples are not positive, these samples are negative, but these samples have been predicted by the model as a positive. So this would be the false positive. Similarly, in this second cell, the model samples are actually positive, here we have the 8 positive samples, but these samples have been predicted as a negative by the model. So but these samples are positive, so this would be the false negative. Second cell will represent simply the false negative. And if the samples are positive and the samples are also being predicted positive by the model, so this would be the true positive. So if we want to calculate the accuracy, precision and recall with the help of the confusion matrix, we can use this formula, TP plus TN divided by total number of samples. I have already explained what is the TP, what is the true positive, what is the true negative. So here 60 is the true negative and 10 is the true positive. So you can use these values in order to find out the accuracy. The accuracy is the ratio of the correct predictions, means ratio of the true positives and true negatives, means summation of the true positive and true negative to the total number of samples. So here we have the 60 as a true positive and 10 as a true negative. So you can simply find out the accuracy. But generally accuracy is not preferred if the data set is imbalanced. If the data set is imbalanced, we need to compute the precision, recall and F1 score. So precision, what is the precision? Precision is the fraction of the true positive to the total number of predictions made by the model. So here you can see the true positive is the 10, and how many predictions the machine learning model, how many positive predictions are made by the machine learning model. So positive prediction कितना आपका? Positive prediction is 10 plus 22. So precision is simply the ratio of the true positive to the total number of positive predictions made by the machine learning model. So it is coming out to be 0.31. So this is not the same data on which we are working. This is a different data, but in order to just make you understand, I am using this data. So in order to just make you aware about the accuracy, precision and recall, I am simply using this data. Then recall. What is the recall? Recall is the ratio of the true positive to the total number of positive samples in the data set. So what is the value of true positive? True positive is 10, and how many positive samples are there in the data set? There are the total positive samples, 18 positive samples are there in data. So recall is nothing but the ratio of the true positives to the total number of positive samples in the data. So it is coming out to be 0.55. So here you have understood what is the precision, recall and F1 score. F1 score is the simply the harmonic mean of the precision and recall. If there is more samples in the one class and less samples in the other class, that means the data is imbalanced. So in order to make the balance, we simply use the F1 score. F1 score is 2 times precision times recall divided by the precision plus recall. So this is the last, this was the last step of this project. Here we have already computed the precision, recall and F1 score, and we have already displayed the confusion matrix. So we have already understood the meaning of the confusion matrix and why do we display the confusion matrix. Just to know how much our model got confused in classifying one class as another class, we simply use the confusion matrix. Now this is the end of the project. Now guys, if you like this project, just subscribe this channel and share this video with your friends also. And thanks to all of you for watching this video. Thanks again to all of the viewers.